All right, one more example for 1.0.2, and again, I have a little bit of a point to this one other than just plugging in, which you're probably not going to be too freaked out by. What I want to say here is that we're going to plug in numbers, they have units attached, we want to work with them. It is not expected that you are any sort of expert on brightness or luminosity or distance. I am not. My take on it is, in a math class, you should be able to manipulate these, come up with the correct final answer, and maybe that'll even give you some insight into what's going on in this problem. So for this one, we're told that the brightness B of a light with source luminosity L at a distance D is given by, I know it doesn't say that, I'm seeing that there are words missing from this, the formula B equals L over 4 pi D squared. Okay, so in this problem, we're given that a 200 watt bulb has luminosity of roughly 4,000 lumens. So that's going to be our L value in this formula. So I'm going to go ahead and put in the top 4,000 lumens. I feel like that shouldn't be plural, so it won't be. See, not a master of all things units, but we're going to try and be really careful and practice with them. We're interested in its brightness at a distance of 25 inches. So our D is going to be 25 inches, and that whole thing needs to get squared. And really all this becomes is a simplify problem. So I'm going to go ahead and try and reduce the fraction a little. I will say that in general, I'm fine with approximate answers, so converting this into a decimal to word problems. For these early sections, I'm not going to be doing a lot of that, and I've even asked in your homework for you to keep some exact, just because I want you to work with the simplification, the exact numbers. The point of this is kind of the arithmetic, so jumping to a calculator defeats that. I do see, for simplification purposes, that the top and bottom share a factor of 4. And I also see a 25 I can work with, but I'm going to rewrite once before I do that. So I have 1,000 lumen per pi times 25 squared inches squared. And really all I did in that step was break up the square so that I have the square unit separated off from the number squared. I can figure out what 25 squared is. I believe that's 625, but I left it on purpose because I'm looking at that 1,000 thinking 1,000 is easily divisible by 25. 1,000 is 100 times 10. And 100 is 25 times 4. So I can cancel out one of these 25s completely. And then it also looks like I have a 10 in the top and a 25 in the bottom. So I can cancel out a 5, which is going to leave me a 5 in the bottom and a 2 in the top. So if you can keep track of all of my mess, I have a 4 times 2 on top. So I get 8 lumens. In the bottom, I have a 5 pi, and I'm going to do that whole trick of separating off the units again. With fractions, when everything's multiplied, you can just kind of split that up as you want. So I'm going to separate off the lumen per square inch. So again, in general, decimal answers to applications, I'm fine with that. There's generally some imperfection when we're modeling anyways. But here I'm just trying to work with the exact numbers. And what I was saying about the insight shows up here. Notice we get lumens per square inch. Lumens told us something about how much light the source was giving off. So this is basically averaging that amount of light over an area. So that's really what brightness is about, is taking the amount of light at the source and then figuring out at a certain distance how much area is that hitting, and then just making basically a density calculation for that. Okay, so hopefully that was helpful.